quiz 3 for Math 213. You're given this mess of a diagram and asked, figure it all out. Figure out what every letter is in terms of angle measure. So, where to even begin? Well, I like starting at A here. I don't know if you have to go alphabetical. Actually, I know you don't have to go alphabetical. But I know that A is the supplement of 143. So 180 minus 143 equals A. So you do that subtraction and you get 37. So I got A is 37 right there. And then I could say that B is the supplement of A, or I could say that B and 143 are opposite angles, so they have the same measure. One way or another, you get that B is 143. All right, step in the right direction. Still got a long way to go. Where to go next? How about C? Let's go alphabetical through this whole thing until we can't continue to do that. So C, because these lines are parallel, C, the angle measure of C must be the same as this angle measure over here, which is the same as A. The point that I'm trying to make is C is also equal to 37 degrees. So I got A, B, C. I can now figure out D. I know that 180 minus 85 minus 37 would be equal to D. I should have written that differently. 180 minus 85 minus 37 equals D. And where that comes from is I have 180 degrees here, and I'm using up 85 of them here, so that leaves me with 95 left. And then 37 of them more. So if I can do, what did I say, 95 minus 37 in my head, I think that's 58. Then that would be my angle measure D. And we can check that. Let's see, 58 plus 85 is 143. And 143 plus 37 gives me 180. So yeah, that checks out. What about E here? Well, I guess I can use the same logic and I could say 180 minus 85 minus 58 will be equal to E. So again, 180 minus 85 leaves me with 95 to deal with. And 95 minus 58, I should just pull out a calculator, but I'm stubborn, is 37. And oh yeah, of course that's 37 because I have this line and this line, so these two angles are opposite each other. So the minute I knew this was 37, really I knew this one was 37. All right. What about F? Well, I got a triangle here, and the sum of the interior angles in a triangle has to be 180 degrees. So again, 180 minus 37 minus 90, let's go in order, has got to be equal to F. So 180, using up 90 of them, leaves me with 90 more. 90 minus 37 is 53. So F must be equal to 53 here. Okay, I don't know, kind of, they seem to be going in order, so the next letter alphabetically would be H. I wonder if I can figure out H here. Oh no, that's not true, it would be G. E, F, G, H. Sing the alphabet song with me. And we can figure out G. And the way we can figure out G is because this side length is the same as this side length. This right here is an isosceles triangle. And if this is an isosceles triangle, the angle G must be the same as this angle, which is 48. That's kind of nice. And if this is 48 and this is 48, I have a triangle. The sum of the interior angles in a triangle has to equal 180. So if I do 180 minus 48 minus 48 more, well, let's see, 2 48s is 96. And 180 minus 96 is 84. So I think I get that H is equal to 84 here. And F must be the supplement of, that's not an F, that's a K. K must be the supplement of H because I have this straight line. So this plus this must sum to 180. So 180 minus 84, which is what, 96, must be what K is equal to. Can I squeeze that in here? Sure. What other letters? E, F, G, H, I, J, K. There's probably not an L because L's are hard to write because they kind of look like ones. So I guess I jump up to M up here. And I can figure out M because I have a triangle. And if I have a triangle, the sum of the interior angles has to be 180 degrees. So I could take 180, a lot of 180s in this problem, and subtract 96. And that leaves me with 84, FYI. And then subtract 58. And that leaves me with 26. This is making my head hurt doing all this math in my head. But I think you get 26, so I think that means that M here is equal to 26, which also means this unlabeled angle here is 26. So I can figure out angle P because I know that 180 minus this 85 minus this 26 is 95 minus 26, which is 69. Yeah, because 69 plus 26 more is 95, which 85, 180, yeah, that checks out. So this is, I shouldn't even be writing 69 here. I should be writing P, which is the letter this guy is, just like this 26 was really M, and this 96 was really K. Fine. So I figured out that P over here was 69 degrees, and I can now figure out R because it's the supplement of P. And so the supplement of 69 degrees, 180 minus 69, leaves me with 111. And finally, I could figure out S. See, I guess I have a few options in terms of how to do it. I think the easiest way is go back to the fact that these are parallel lines. So P and S must have the same angle measure, aka they must be congruent. So that must be a 69 there as well. And I believe I filled in all those letters. Man, that was a lot of work. Although I think if you had a calculator, that wouldn't be quite as bad. So hopefully that's doable. Okay, no more calculations to do. It's the good news, I guess. But now you're going to draw tessellations, which are kind of hard in their own right. Sketch a 6, 3, 6, 3 tessellation. What that means is that if you pick a vertex and you kind of look at the shapes that go around that vertex, you're going to find, if you go clockwise or counterclockwise, a hexagon, and then a triangle, and then a hexagon, and then a triangle. So maybe I pick this vertex right here. There's my hexagon. There's a good looking triangle right there. Let's see if I can draw another hexagon over here. Pretty decent little hexagon. And then another triangle right here. Hey, cool. From this vertex, hexagon, triangle, 6, 3, 6, 3. Let's see if I can make that continue to work. Maybe I'll choose this vertex right here. From this vertex, I got, here's my 3, or here's my 6, so I need a 3 over here. So in order to have everything be the same size, I'm going to try to make those 3's the same. And this kind of starts to give you the outline of a hexagon right here. You can kind of see it. There's one side, two sides, three sides. 1, 2, 3, 4. Maybe not the prettiest hexagon ever drawn. We'll call that good. No, we won't call that good. Come on, I can do better than that. Let's make this thing a little better. There we go. So one side, two sides, three sides, 4 sides, and 5 sides, and 6 sides. So from this vertex, 3, 6, 3, 6. Or I guess I was going 6, 3, 6, 3. Cool. What about this vertex right here? Well, there's the 6, there's the 3, there's the 6. Hey, there's the 3. Looks like this works out. So you could do more if you want to, but since it only says 3 vertices, I'll pick on these 3 vertices, and I'll call that a decent enough picture of my tessellation. Yeah, I'm going to do that. Yeah, I'm going to do that. I'm going to move on. Maybe I'll come back and fill this. I'm going to fill this in a little bit more, but I'm not going to have you watch me do it. Some extra in blue there in case you're curious. You can kind of keep drawing these triangles and hexagons. I kind of think it's fun. Don't roll your eyes. But you don't have to. Maybe I'll even say this, like, red is sufficient for answer. The blue is just me screwing around. Okay, a little bit more with tessellations. Here is a tessellation that I did not want you to have to draw. Kind of cool looking, I guess, maybe. And what you're supposed to do is sketch the dual of the tessellation shown below, and specifically include enough so that you can name the dual. So, okay, the way you sketch a dual is you take each of these shapes and you kind of put a dot in the middle of them. Essentially, you create a vertex at the center of each face here. So I'm just going to do a whole bunch of them. I'm not going to do them all, don't worry. You won't have to sit here and listen or watch me draw little dots for too long. Maybe I'll call that good for now. Can't leave good enough, well enough alone, whatever that saying is. I'm going to call this good, I promise. And now I'm going to connect these dots, but the way I connect these dots is going to be, I don't know, I have to be a little bit careful about it. I only want to connect dots if the face that define those dots share an edge. So think about these two dots right here. I do want to connect those because this face and this face, this green face and this blue face, share this edge right here. So I connect these two dots right here. Similarly, I'll connect these two dots because these faces share an edge, and these guys, and these guys. Hey, look, a square. How about that? And I'll connect these guys, and I'll connect these guys, and these guys, and these guys, and these guys. Hey, that looks kind of like a hexagon, except that I'm not much of an artist. And so let's just kind of keep connecting where appropriate and see what happens. That's probably enough for you to name it. Maybe I'll even write this. Red is enough. ENOUGH? Sure. For the answer. I'm going to do a little bit more because I feel like it to really show the pattern that you got going on here. Connect those guys and those guys and these guys. These down here. These guys. And all right, maybe I call that good. Kind of filled this in. I say I call it good, and then I just keep on going. Kind of filled things in a little bit. At least I should take care of the dots that I made, right? The new vertices. Pretty quick. Okay, so now you have this kind of start of a tessellation here. And you're asked to name it. So to name it, pick a vertex, any vertex you want. I don't know, let's pick, this looks like a pretty good vertex right here. And we'll go either clockwise or counterclockwise, it doesn't matter, around this vertex and list the number of edges in the shapes that use this vertex. So I got this hexagon right here, that's a 6. Then I got this square right here, that's a 4. And so remember, I'm going around this vertex, 6, 4, 3, 4, 6, 4, 3, 4, 6, 4, 3, 4. So the name of this tessellation is 6434. It turns out that you could have started here and called it a 4346. And so just so I don't have to answer this question 10 times when you turn in your quizzes, yeah, that's right also. And yeah, that's right also. And yeah, that's also right. And can I just put or ... Maybe I've listed them all. No, I doubt I have. I could probably do some of these backwards. Well, maybe I have listed them all. No way I have. Well, who cares? My point is there's lots of different names for this thing. You just have to have the numbers 6, 4, 3, 4, either in that order or in reverse order. So like 4, 3, 4, 6. Like I have right here. And you can kind of shuffle them up. You can cycle them through however you want. So there's lots of different possibilities. Anyways, that's the tessellation that this duel creates. That's your answer. I'm going to stop this quiz here.